All right, can you see what I'm sharing? Right, can someone confirm they can see my screen?
Yep.
Okay, good. All right, so go ahead and take a few minutes and work on these 4 integrals. So basically, if possible, let's get exact values for all 4 of these. So hopefully you realize you're only having to do 1 antiderivative, but you should get 4 different values here. So I'll give you a few minutes to work on those, and then I'll check on you to get some feedback.
2 over x negative 2 negative 1 over x. Negative 1 0.5 be right.
All right, so first thing we should probably do is figure out the antiderivative here. So how can I find the antiderivative of 1 over x squared dx?
X to the negative 2, and then you...
Right, so you're rewriting it's a good first move. And what does that yield?
X to the negative 1.
We agree with that? X to the negative 1?
I agree with that.
Wouldn't it be negative?
Yeah, so remember when you power rule, so when you have to increment the exponent. So add 1 to the exponent and then divide by whatever the exponent is. So really what we're going to have is negative 1 over x, evaluated from 1 to 2. So now we can use this antiderivative to evaluate all 4 of these integrals. Maybe. So what's the value of this first integral going to be?
Negative 1/2.
Got to vote for negative 1/2. We agree with that. So let's go through it. So I'm going to plug in the both the limits. So negative 1 over 2 minus negative 1 over 1. So that should come out to negative 1/2 plus 1, or positive 1/2. All right, how about this next one?
Negative 1 over 100.
Negative 1 over 100, how are you getting that? Or sorry, is that your final result, or we just
Oh, no, just the first.
Okay. Gotcha. Keep on going.
and then minus parentheses -1/1.
So basically -1/100 plus 1, that'll come out to be 99/100. All right. And hopefully we're noticing a pattern here. What should my final result be on this third one here?
999/1000.
Yep. So let's say I take away the upper limit and just replace it with infinity. Do we have an idea what this final integral would be?
1.
So let's hold that thought for now. Let's see if that actually, if we can actually compute that. So that's what we're working on. I see a lot of stuff in the chat. What's going on? 1. Yep. Okay. So let's move forward. So let's generalize this a little bit. The one I just showed you was the integral from 1 to infinity of 1/x². Now I have this just 1/x². So basically what I want to do is this. I want to come up with some kind of conjecture here. I want to know what values of t this integral will converge for. So integral converges. So let's do this. We know that, well, we don't know what happens at 0. We know what happens at 2. So I know that at 2, this integral converges. It actually gives us a value. I'll go ahead and spoil it for you right now. The integral of 1/x² from 1 to infinity is indeed 1. So let's take it. We can take that for granted that when t equals 2, this thing converges. So let's work from there. What if we have something bigger than 2? Like what if we have 10? Do we think that integral will also have a finite value? Can we actually get that one to converge? So I got 1 vote for no. Let's actually take a look because we can do this integral. So let's take a look at the integral from 1 to infinity, or I guess we can just do this. We can get an idea if we just go from 1 to 100 of x⁻10 dx. So what would this integral be? Or what would the antiderivative be?
-1/9 x to the power of -9.
Okay, so yeah, I wrote basically a different version of what you said, but yeah, -1/9 x to the 9th in the denominator. So basically the first thing I'll do is plug in 100 to this. That'll be 100 to the 9th power, which will essentially be, 1 times 10 to the -18th. So very, very small. This is going to end up being very, very small. So if I let this number, so what's going to happen if I keep letting this upper limit here go towards infinity? What's going to happen to this this term here? Chat says it'll go to 0, and that's true. So basically, this is going to get bigger and bigger. So I think we can safely say that this is going to converge as well. So let's say anything bigger than 2. This is going to converge as well. So all the way up to infinity. So there's got to be some, let's go backwards now. Do we think this thing will converge for any value of t less than 2 as well? Or is there going to be somewhere where this doesn't work? And just to kind of trigger your memory on more recent things here, does this look like something else we've seen in class pretty recently? This integral here.
A P series?
Yeah, I mean, it should resemble a P series, right? So, and that's not an accident. So many of you have asked me in class, on the chat, or maybe even in office hours, is there some kind of relationship between integrals and series? And they're not the same, but they are, they're good analogs for each other. And we're seeing the same kind of thing here. So what values of t, so relating this to a P series, what values of t do you think I can say this thing converges for?
Anything greater than 1.
Anything greater than 1. So open parentheses here at 1. So this integral will converge for t strictly greater than 1. So I think Mark did a pretty good job of, using the harmonic series to explain why that's the case. I'm going to do something a little different here. So let's derive this P series test using this, generic integral. So the first thing I'm going to do here is take the antiderivative of this. So keep in mind that my only variable in this situation is x. T is just going to be some constant for now. So the first thing I'm going to do is rewrite this. So I have x to the negative t dt. And if I do the power rule on this, which I'm allowed to do because t is just some constant, this becomes x to the negative t plus 1 over negative t plus 1. Actually, there's one more thing I got to do here. So infinity is not a number. So something I'm going to do in the meantime is I'm going to replace infinity by this new variable. I'm going to call it b. And instead of taking the integral from 1 to infinity, I'm going to take the integral from 1 to b. So now if I take the antiderivatives, now I just have to carry this limit operator with me until a time when I can actually apply it. So this will be x to the negative t plus 1 over negative t plus 1, and I'm going to evaluate that from 1 to b. Any questions about anything I've done so far?
Is that like an open form?
Yeah, we're going to work towards a closed form. So basically our goal here is to, at some point I'm going to plug in b for x. But I'm going to wait a little longer. Our goal here is to figure out what values of t that this limit will actually exist for. But since I'm calling this the P series test, so you probably already have ideas about what values of x this will actually work for, or what values of t, I'm sorry, this will actually work for. So define or try to find this limit. One thing I can do though, remember this limit is all about b. As far as I'm concerned, t is a constant. So I'm going to do this. I'm going to just pull that out. So 1 over negative t plus 1 times the limit as b approaches infinity of x to the negative t plus 1. And I'm evaluating this still from 1 to b. Now let's actually plug in these limits. So b to the negative t plus 1 minus, if I plug in 1 to this, that's just going to be 1, right? So really, this thing right here, what's the only value of t this can't take? Yeah, I know I got something in the chat. I'm having a hard time seeing. So a lot of votes for 1, and hopefully that kind of makes sense with what you know about this integral and the p series. This integral, the integral of 1 over x is not something the power rule works with. So the only thing I should have specified right away is that t cannot equal 1, because if t does equal 1, and this is a very, very different situation. But now we have to look at is this. We have b to the negative t plus 1, and I want b to get really, really big. So if b is going to get, so here's what I want to happen. I want b to get really, really big, but I want this overall term, b to the negative t plus 1, I want that to stay finite. So let's go ahead and do one more thing here. So 1 over negative t plus 1 times this limit. And I'm going to break this up. So b to the negative t times b to the 1 minus 1. All right. So now I want b to get really big. Obviously, this b in the numerator is going to get overwhelmed by what's going on, or I guess not obviously. We have to figure out what values of t are going to cause the denominator to get bigger faster. So what values of t am I looking at here? When will this limit exist?
When t is greater than 1, the denominator would get bigger than b.
Right. So really what I have is, this is b to the 1 divided by b over t, so b to the t. So the only way this is going to converge is if t is greater than 1. That's the only way this denominator will grow faster. So like I said, Mark gave you a justification for why the p-series test tells you what it does. This is another way to look at it. Any questions before we do some more with this? All right, let's go ahead and move on. So what we're going to do for the rest of today is, and I'll give you a little background on what we've done in class so far, just to kind of recap. For most of the series we've looked at, we've really been concerned about one question: does that series converge or diverge? And in most of the cases, even when you know it converges, you can't find the value of the sum. It's just one of those things that it is far more difficult than it appears. Really, there's only one situation when we can get our hands on that sum. So what's the only situation we have where we can figure out what the value of that sum is?
Geometric series?
Those are geometric series, right? And that's not what we're looking at right here. So this gives you a little bit of a weapon to figure out what the sum is. So let's look at an example here. I have this integral from 2 to infinity of 3 over x plus 4 to the 3/2. So hopefully by now you're seeing the analogy between a p-series test and integrals that look like this. So based on the way this, based on this function I'm about to integrate, should we expect this to converge to some number, or should we expect it to diverge? Okay, I gotta vote for converge. Anybody else want to agree with that or vote for diverge?
Would it diverge?
Okay, well, I got one vote of each, so let's take a look at it. So I want to integrate this, so what's something I should do first? Or maybe you don't do this because you don't need to, but I think it makes it a little easier to digest. So from here, I'm going to insert that limit again. So the integral from 2 to b of 3 times x plus 4 to the negative 3 halves dx. So now I'm ready to take the antiderivative here. So what is the antiderivative of this function?
Would it be negative 1/2 times x plus 4 to the negative 1/2?
So negative 1/2 times x plus 4.
Sorry,
Mhm.
negative 1.5 for the start.
So I got negative 3 over 2 times x plus 4 to the negative 1/2. How do we feel about that?
Yeah.
See what the chat says. I got to vote for positive 6. So let's take a look at something here, because I understand where this coefficient came from, but let's go through it a little more slowly. And this is one of those things that kind of gets polished up over time, but let's take a look. So I know that power rule says that I do this. I'm going to increase the exponent by 1. So that brings me to negative 1/2. Then I have to divide by that exponent. And I think what tripped up Bo was he said 3 divided by negative 1/2 is negative 3 over 2. But that would be the product if I were to multiply 3 and negative 1/2. So really, what is 3 divided by negative 1/2?
Negative 6.
Negative 6. So I'm actually going to do this. I'm going to do a rewrite. Negative 6 divided by the square root of x plus 4. So let me go ahead and stop there, make sure everyone's still with me. Any questions about how I got to any of these computations here? All right, now I'm going to go ahead and plug in the limits of my integral here. So I got negative 6 over the square root of b plus 4 minus a negative. So I'll just do plus 6 over the square root of 6. So now we can actually apply the limits. I'm going to stop carrying that around with me. What is going to happen as this b in this denominator here gets very, very large? So this numerator of 6, what's going to happen to that as b gets very large? All right, chat says, so it'll get close to 0, and that's exactly right. As b gets very big, the denominator is going to get large with no bound, so that's eventually going to go to 0. And this other term, 6 divided by radical 6, is just going to be radical 6. So those of you who thought this was going to converge, it did. So we have a final result of this integral as being the square root of 6. which if we relate this back to the P series, what's the value of P with this original function here?
Three over two.
3/2? Yep, we have 3/2, and that is bigger than 1. So that means we should have expected this to converge. Any more questions on this one before I move on? All right, next one. All right, so integral from -infinity to -3 of 1 over radical 8 minus x. So same question here. Do we think this will converge or diverge based on the function I'm trying to integrate? Okay, I got to vote for diverge. Got another vote for diverge as well. So let's make sure. So again, I would like to rewrite this. So what is the antiderivative of this function this time?
Two times the square root of 8 minus x.
2 times the square root of 8 minus x. We agree with that?
Yes.
Good. So now from here, let's keep on evaluating. So now I believe I can put in my values. So if I put in -3 here, I'm going to get 2 times the square root of 11. And then the other one's going to be -2 times the square root of 8 plus b. So 2 over radical 11 is clearly finite. So let's do this. Radical 2 times the square root of 11 minus the limit of b going to infinity of 2 times the radical 8 plus b. So as b gets very, very large, what's going to happen to this? So it reaches infinity. So you got one vote for reaches infinity, and that is indeed what happens. So this is going to, this diverges. And hopefully based on the value of p we have here, that's not a surprise. So what is our value of p for this series here? That says 1/2, 1/2. So, and I also had a vote in there for -1/2. Remember that we're basically assuming the negative because p series basically, if I write it in series form, you have 1 over n to the p. So we're basically already assuming the negative. You're assuming that this term is in the denominator. So this one is going to be p equals 1/2. And that is less than 1. So yes, you should expect that to diverge. Any questions on this one? All right, let's look at this guy. So I'm going to start this off by bringing the limit in first. So how should we attack this?
Move the denominator up to the top.
I'm sorry, what was that?
Move the denominator up to the top.
That's actually not going to, we're eventually going to have to undo that this time.
Do we want to do partial fractions?
Yeah, we need partial fractions. But one thing I forgot to ask this first. Would we expect this to converge or diverge?
Converge.
Okay, I got one vote for converge. Is this a, so let's put this in series form. If I had a series that looked like this, 1 over n squared plus 7n plus 12, is this a p-series?
Yeah.
It's technically not, because p-series is very, very restrictive. A p-series looks like this: 1 over n to the p. One term, numerator is 1, denominator is n to some constant power. So I do not have that here. So I can't use the p-series test, but there's another really powerful tool that you all learned, I think maybe late last week, or maybe it was Monday. Yeah, so Layla and Tony are both using the magical word there, compare. So yeah, I can compare this. I know this thing right here is going to be less than or equal to this series. Am I okay to make that statement?
Yep.
Yep. So I mean, yeah, 1 over n squared is going to be bigger. This denominator is going to get even bigger when I add 7n and 12, because n's always positive. So hopefully that tells you that this integral should have a limit. It should converge to a value that we can find. So we want to do partial fractions, which is good. So what would those partial fractions look like? Or I guess, what do we need to do to this quadratic before we can think about that?
Factor the denominator.
Okay. How does the denominator factor?
X plus 4 times x plus 3.
Okay. So those are good factors. And what's the partial fraction decomposition going to look like based on that?
A over x plus 4 plus b over x plus 3.
Right. Yeah, this is about as simple as a case as you're going to get. I mean, 2 linear factors, nothing repeated. So then from here, if I multiply both sides to clear the denominators, I get this: 1 equals a times x plus 3 plus b times x plus 4. All right, so, and just to kind of speed things up here, this is a technique that I might have showed a few of you in office hours, but I don't think Mark widely uses, but I'm allowed to do this. I'm going to let x be -3. And if x equals -3, then all of this becomes this: 1 equals a times -3 plus 3 plus b times -3 plus 4. So from there I get 1 equals b times 1, which gives me that b equals 1. Any questions on how I did that or why I'm allowed to do that? Is there another value of x I can choose that would give me the other value?
-4.
-4. Yeah, basically, I'm strategically picking x values so that I can make one of these vanish so I can solve for the other one. So 1 equals a times -4 plus 3 plus b times -4 plus 4. That comes out to 1 equals a times -1. So a is -1. So what I've just shown is this, and I'm going to write a positive term first. This is equal to 1 over x plus 3 minus 1 over x plus 4. So any questions about that before I get into actually integrating this now? Okay, so I want the limit from b to infinity of the integral from 0 to b of 1 over x plus 3 minus 1 over x plus 4 dx. So what is this antiderivative going to be? And I got chat messages. Why the 1 over x plus 3 minus 1 over x plus 4 again? So let me answer that question with this question. Are we okay with the values of a and b that I found? Yep. Okay. So remember, our first shot at, partial fractions here, I know that 1 over x plus, 1 over this quantity, x plus 4 times x plus 3, is going to equal some constant over x plus 4 plus some other constant over x plus 3. So all this algebra that I did the next few lines here determine what those constants were. And then just because I prefer to have my first term be positive if I can help it, I flip these at the last step. Okay, so back to the integral. Oh, so what is this antiderivative? Chat. Oh yeah, no, I'm not. So me plugging in the x values, plugging in those x values was just a means to an end. That was just to help me find a and b. And just to kind of remind you way back to talking about constants, parameters, and variables. What variables are there in this situation here? Chat says x. Yeah, the only variable here I have is x. A and b are not variable. They are constants that, for a time we just didn't know what they were. But here's the beauty. Here's why I can do the trick that I did. A and b have to be the values they are, no matter what x is. So if I can choose an x that makes a irrelevant or b irrelevant, then solving for the other one is really easy. All right, back to this. What is the antiderivative of these two rational functions that I ended up with? Yeah, I got votes for natural logs. So natural log of the absolute value of x plus 3 minus the natural log of the absolute value of x plus 4 evaluated from 0 to b. So let's take a look at this now. Do we think this thing is going to converge? What happens when I put b in for either one of these? So Rodolfo is saying that it's going to be 0. So let's think about this. If I plug in b, let's just look at the natural log of b plus 3. As b gets very big, this whole term right here is going to get very large. this whole term's going to get very large. And subtracting them from each other, basically you're comparing natural log of infinity to, you're doing infinity minus infinity, which is, not really something that's easy to think about. So I'm going to go ahead and remind you of something that you probably haven't seen in a while, if my last class was an indicator. But here is something that I am allowed to do. The natural log of x plus 3 over x plus 4. So hopefully, I mean, you might not have used that in a while, but hopefully it looks familiar, your logarithmic properties, that basically the ways you can combine them. If I have log of A minus log of B, that's equal to the log of A over B. So I'm just applying that identity here. So now I can start plugging things in. So I'm going to have the natural log of B plus 3. Actually, I want to limit. And I'm going to leave out the absolute values because all these things are going to be positive anyway. So the natural log of B plus 3 over B plus 4 minus the natural log of 3/4. So now natural log of 3/4 is well defined. That's going to be finite. What's going to happen to this term on the left as B gets very, very big?
It's gonna approach ln of 1, which is just 0.
Right. So, you can always treat, rational functions like this. Doesn't matter if the log is out there. You can still look at the inside here, and really you're comparing degrees. So both the numerator and denominator are degree 1. So that means this is going to trend towards natural log of 1 minus the natural log of 3/4. Natural log of 1 goes to 0. So really what you just have is the negative natural log of 3/4. Any questions on any of that? Okay, here's what I'm going to do. We have 6 minutes left. There is a quiz today. What I recommend is this. The quiz is due at 11:59 tonight. What I recommend is this. I recommend you, as independently as possible, work through example 4 here. I mean, this one is pretty clearly, not like a p-series. This is going to be a little harder to think about that way. But you can still go through the improper integral process, which is really, hopefully you've realized that, with the exception of that limit operator, this, integrating works the same way as you've been used to. So my suggestion is this: work through example 4, come to some conclusion on it. First, find out if it converges or diverges. If it converges, get me a value, an exact value. After that, whether you do it while you're sitting here or sometime later tonight, take that quiz. But other than that, I'm gonna go ahead and say you're free to go. So if you have any questions about this example or anything else, please stay on. I'll stay on for a few more minutes. Otherwise, I will see you in class tomorrow morning. Now I got a question here. So Rodolfo, are you asking if the entire integral that we just did went to 0?
Yeah, so I was a little confused.
So no, the entire integral does not go to 0, but if you can see my cursor at the bottom of the screen there,
Yeah.
That term right there will go to natural log of 1. Because basically as b gets very, very large, you're just getting closer and closer to 1.
Yeah.
So that term right there will go to 0, but this, negative natural log of 3/4, that will still be there.
Yeah, because I was a little confused just because of how, like, if you don't apply the rule, I would have assumed it would have been like ln, like, and the x plus 3, x plus 4. They would have just turned into like ln of x minus ln of x, because I guess if x goes to infinity, I guess the 4 and the 3 wouldn't matter that much. So that's why I
Right.
was thinking like it'll go to 0.
Right, but then you have, so yeah, these are both going to get big, but it's really hard to know if one of them's going to grow faster than the other. So if you just think of them basically as, all right, I have a very large number on the left and a very large number on the right. So if I subtract them, I should wind up with 0.
Yeah, that's what I was thinking.
And even though that ended up happening in this case, that's kind of a dangerous way to look at, because you might have 2 terms that you're going to subtract from each other.
Yeah.
That both go towards infinity, but that doesn't mean that they go towards infinity at the same rate.
Yeah.
So you might have one overwhelm the other. Like you might have something like this that that does not trend towards 0.
Mm-hmm.
So I want to actually give an example on that. So this is not directly related to this here, but let's say I had the limit as x approaches 0 of x times 2 to the x. So slightly different, but I think this will help me make the point that I want to make. Actually, not 2 to the x, 2 to the 1 over x. So if you look at these individually, as x gets closer and closer to 0, I mean, this thing right here will kind of go towards 0.
Yeah.
But this thing here,
it'll reach infinity. Yeah,
it'll go towards infinity. But you can't make a conclusion from that, because I don't know which one of these is more significant. Will this term on the right grow fast enough to keep this whole thing positive? Or will this x on the left, will that make the whole product just trend towards 0?
Yeah.
So, this you can't always apply those pieces in an intuitive way.
Okay.
And chat says 2e to the 2 over e. Yeah. Nunzil, 2 over e is the limit. That is the value of this integral.
Question? Oh, sorry.
Oh, you could go ahead.
I did have a question about example 4. Are we turning this in along with the quiz?
No, this was just I was just suggesting that you do this as just one kind of test yourself more or less independently before you go off and do the quiz.
Okay. I'll let him ask his question, and then I have another question after.
Okay.
I was just gonna ask is it possible to set up office hours?
Yeah, send me an email with some times you're available.
Okay. And would that be able to like work for this week, or would it be for like next week?
Yeah, I'll have some time this week.
Okay. All right. Thank you very much.
No problem.
Hello.
Hello.
Oh yeah. Okay. My question, it's probably a very simple question. Way back before we started example 1, can you go to this? I don't know if the stuff is still there.
Yeah, it is.
Before we started exam.
This one here, the first slide?
No. Let me see if I can scroll up in the chat to see what it was. Okay. The antiderivative of that one was negative 1 over 9x to the negative 9. I believe
Okay,
it
let me
was.
go back. Yeah, so yeah, x to the, let me get that bullet out of the way. Okay,
Okay,
yeah.
and then can I see the next page?
Mhm.
Okay. No, the next one after that, please. Sorry. Oh no. Okay, what I was confused about was one, the antiderivative was negative 1 over that integral, and then the other one was just the integral, and it looked like they were the same thing.
-1 over the integral? What do you mean by that?
No, I mean the negative, and not the integral. I mean negative 1 over 9x to the negative 9, and the other one was something like just, it didn't have the it in the denominator. I don't know how to explain this.
Okay, let me see if I can go back and actually it'll be easier to compare if I just shut that off. All right, so where did I do that integral? Okay, so oh, I think I know where the confusion is here. So let me go back. So this one here, let me do this one a little more slowly because I kind of skipped a step. I skipped a step on this one that I did on that later one. So the antiderivative of x to the negative 10th dx would be equal to x to the negative 9 over negative 9. Then from there, I could write this as 1 over negative 9 x to the 9.
Okay,
So
that's
that
what I
middle
was.
step was, I think, you were missing.
Yeah. Okay. Thank you.
No problem.
Stephen, I had a question about the integral test. Is there a situation that, like, if we still, okay, is there a situation where the limit still does not exist with the improper integral test?
Yeah, we did one. So yeah, this example here.
Oh, okay.
Yeah, so this this term right here, you know, as b gets really big, this one is going to, this term right here is going to go to infinity all by itself. So yeah, even though this first term gives me 2 radical 11, this is going to grow without bound.
Cool.
So yeah, this integral has no, it can't, I can't give you a value for it. It diverges.
Awesome. Thank you.
No problem.